So let's prove that if two vectors are parallel, then they never cross. Simply, then their cross product will just be 0. That means they will never cross because they are parallel, right? Now, let's get vector v1, maybe as 1, 2, 3, or 1 minus 2, 3, just to make it interesting. We need to make this vector, so we use these brackets for vectors and we put a bar on top, or we make it bold. But unfortunately, as you write in exam, you don't have time to make things bold. You're not a computer, you don't have a computer. You just continue and write it like that with a bar on top, instead of writing like this. That we write scalars like that, we write vectors with a bar on top. In the textbook, you will see they write vectors as solid or bold V, and scalars with they just don't make it bold, a thin V. And in that case, well, it can be W, it can be anything. So let's get what will be a vector that is parallel to this one. We can get another vector. We can just multiply this vector by 3 or any scalar number to make it just parallel. We can even multiply it by -1. When it's like this and maybe it's facing that way, when you multiply by -1, we'll just get this one back. You just get the same vector facing on the opposite direction if you multiply this one with -1. For interest's sake, you can do that and prove this question, because after getting this one like that and getting the other one like that, the angle between them will be 0 or 180 degree. As you can see there, for this one you can claim is 180 degree. That will be the safest way to go about, because we are going from that direction to this direction. There's the angle between them, that is just 180 degree. Well, if their angle is 180 degree or 0 degree, that simply means they are parallel. So let's get this one. We can maybe make it even much interesting. Put another vector u and multiply this one with -2. So let's get multiplying up. We are allowed to write like this, by the way. We get a, b, c. So we multiply this 2 on everyone that is inside there. Then we will get, we call it scalar multiple. Scalar multiple. So we can get this one multiplied by -2. Let's get that vector. Will not change anything. It will just change its size and direction. It will not change the fact that it's parallel. So it will get -2. Then -2 here, we are operating like this now. -2 into v. -2v. We are getting that one. That one will be -2 times 1, -2 times -2, 4. -2 times 3, that will be -6. So these two vectors, let's prove if their cross product is a 0 vector. Is a vector that does not have direction. So therefore we'll be proving that it will just they will just be parallel to each other, which is what we are doing in this video. So let's get v cross u. Well, with cross product, it matters to it. You must know that v cross vu is minus u cross v. You can put like this. Well, in this case does not matter, because now 0 vector does not have plus or minus. You can just put 0 vector. It will just give us that 0 vector. So we get in the x head direction, y head direction, and z head direction. We get to put determinants like this, and you put the first one in the middle. So the first one is v. I'll put 1, -2, 3. Then u will be -2, 4, 6. So we put -2, 4, -6. Sorry, -6. Then we get this one like this. We get to simplify it now. The reason why we are doing this video is because one of my students asked me to just show her how to do this operation properly. The operation here comes like this. So you write equals to, then you can put x head already, leave some space for some terms that you're gonna write there, and y head. In other textbooks you will see I, j, k, basically the same thing again. So you put x head, y head, or z head, and z head. So you're gonna put this one plus something plus, you write like this. So the first term, the first number that comes in front of x head, that will go in the x head direction, is, you must know, when you cross the components of y and z, you will get the components, the answer that goes in the x head direction. That's the properties of a cross product. Basically, when you cross two vectors, you will get another one that is perpendicular to them. Cross these two vectors, does not matter what the angle between them is. It can be 10 degrees. What matters is the answer is going to be 90 degrees to both of them. It's going to be perpendicular to both of them when you're doing the cross product. Now, since we put plus here, I advise some of my students to put minus, depending on which one works for them. If you put plus there, you're going to keep the same order of multiplying. The four things that I'll show you now, you're going to multiply the first two minus the last two. You multiply like that. If A is here, B is there, C is there, and D is there. So you multiply AD minus CD for all of them. If you put minus here, if you put minus there, if you did not put minus but you put plus for all of them, when you come for this term that comes inside here, that number that comes inside there, or the term that comes inside there, all you have to do is you must now change the order of which you're multiplying A, B, C, D. You're gonna take what? You're gonna say now BC minus AD for that term. If you put plus, you say BC minus AD. That will be it. That will still be the correct way to go about it. So you still get the same answer. So I'm just gonna put minus. I can choose to put plus. Well, I can do both of them, but this thing is new to you and to most of you, so I advise you to use the one that works best for you. I'm gonna put minus. So we get to multiply the first ones. Now I'm gonna highlight them. The one that goes with x head, you hide these ones, you hide them, you don't want to see them. You're only interested in this 4. Those are the 4 that I'm talking about. So you're gonna say 12, because minus 2 times minus 6 there is 12. I'm gonna put 12 here. Minus, then you put this one, 12. You get 12 again. Okay, so that you will still get like that. Then you continue like that. So let's just write the answer that we just found. We will get 12 minus 12, as we have seen. So 12 minus 12. So the next one is in the y-head direction. The one in the y-head direction will be, you put for y, you hide this y, everything that is under y and that is besides y, you hide it. You are left with this 4. These are the 4 that you are remaining with. So you're gonna say minus 6 minus 3 times 2 there. What is that? So you get minus 6 minus 6. So basically you get that one like that, which is just, if we just erase this 2 guys here, we get minus 6 minus, which order did I take again? I hope I did not, but well, it does not matter for this one because it's gonna be 0. But now I just want you to keep the same order. So because I put minus, I must say minus 6 minus 6. I think I did the same thing as I'm doing now, so I didn't make any mistakes earlier. So if I put plus, however, if I put plus, I must say minus 6 minus 6. For this one does not matter because it's 0, because actually that's what we are proving. Remember, we are proving that it's gonna get 0. But now that order matters if that number is not 0. So just keep that one in mind. So we get minus 6 minus 6. We put it like this. And the last one, we hide for z, we hide like this. Then we get this 4. We hide everything that is below z and everything that is beside z. Everything that is not, that has nothing to do with z, we multiply those ones. 4 minus 4. So you get 4 minus 2 times minus 2 times minus 2 is again 4, positive 4. So the answer is 0x hat minus 0y hat plus 0z hat. So in x direction we get 0, in y direction we get 0, in z direction we get 0. The answer for this thing can also be written as 0, 0, 0. Inside the bracket that are pointing like this, are pointing like pointy brackets like that. So we get 0, 0. We can write that is equivalent to this, which is equivalent to 0i plus 0j plus 0k. Like if you are using that format, you can also go like that. But this again just simplifies to a vector that is without direction, because there's nothing that is going anywhere in any direction in x or y or z. It's just there at the origin of 3D. So we put like this. That is just 0 vector. So we have successfully proven that we will get the two vectors to be parallel if and only if their cross product is making that 0 vector as a cross product of those two, meaning they will not cross. That simply means they will not cross. Thank you for watching this video. I hope you will enjoy it and it will be of good purpose in your academic journey. Please don't forget to subscribe and like this video. Share it with your friends and maybe it will help them, or you will help them as you explain to them. Goodbye.